Some communities in the Philippines are experiencing a series of blackouts due to shortage of electricity in areas where there are no national electrical distribution network. Local officials have been undertaking projects and research to address these concerns. They have also conducted research studies on the various types of alternative energy sources, which can be considered as immediate solutions to solve their energy problem. Starting from paddle wheels used as millstones to grind grains in remote mountains and hilly regions in the developing world, hydroelectricity is said to be the oldest source of energy. The first type of hydroelectricity are storage hydropower, typically a large system that uses a dam to store water in the reservoir. Electricity is produced by releasing water from the reservoir through a turbine, which activates a generator. The second type is pumped storage hydropower, which provides peak load supply, harnessing water which is cycled between a lower and upper reservoir by pumps which use surplus energy from the system at times of low demand. When electricity demand is high, water is released back to the lower reservoir through turbines to produce electricity. Run-of-river hydropower is another type, which is a facility that channels flowing water from a river through a canal or penstock to spin a turbine. On the other hand, offshore hydropower is a less established but growing group of technologies that use tidal currents or the power of waves to generate electricity from seawater. The different classifications of hydropower are microhydro, which produces up to 100 kilowatts of electricity, mini hydro, which produces up to 101 to 10,000 kilowatts, and large hydro produces above 10 megawatts. The very first hydroelectricity power plant built in the Philippines was in Baguio City, called John Hay MHP. It used to produce 560 kilowatts back in 1913. Run-of-river hydroelectricity happens when a portion of the river is diverted into a pressurized pipeline that delivers it to a turbine or water wheel. The moving water rotates the wheel or turbine, which spins a shaft. The motion of the shaft can be used for mechanical purposes, such as pumping water, or it can be used to power alternator or generator to generate electricity. After undergoing the process, all the water is directed back into the river. It can be built in isolated areas or in an area where there is no national electrical distribution network. With very small reservoir and limited civil construction works, they have a relatively low environmental impact compared to large hydros. With only a small stream needed, remote areas can have access to electricity, a necessity for much needed lighting and communications for their homes, medical clinics, schools, and other facilities. With the cost benefits for such less carbon emission process, the future of micro-hydro systems will become more appealing. One of the benefits of the run-of-river hydroelectricity is it is cost competitive. It gives locals an opportunity to be employed from the construction of the run river to the operation of the plants. It is also one of the cleanest renewable energy available.